From the source node, you have to find out the next best state, which is in the local neighborhood, right? Next node which is in the local neighborhood. So what we do is, we will we'll apply a heuristic function for this current node, and we will make a move, or we will find out our next node in the local neighborhood. We will apply heuristic function on that if to both the nodes, right? Source node and the next node. And if the heuristic value of the next node is better than the previous node, we will proceed, right? And if that heuristic value is not better than the previous node, we will check for an alternate in the local neighbor which is having better heuristic than the previous one. So we'll go for that node. So if no neighborhood node is having the better heuristic value than the previous node, we will take any one of the node, and that will be our current state. And from that current state, again we will search for next best neighborhood by applying some heuristic, and we will select the one which is having better heuristic value, and this process is repeated or looped till we get the goal state. So we will see this with the help of an example. This is very simple. Again, I am repeating the concept of this algorithm of simple hill climbing. We will start at the current state, and we find out a particular node, next node in the neighborhood, and we will apply the heuristic to the next node. If the heuristic value is better for that node, we will consider that as current state. If that is not better than the previous node, we do not consider as our next node. We see whether any other node in the neighborhood is available which is having best node. We consider that as our next state. So if no such node exists, we can choose any of them. So this comes as a disadvantage of hill climbing, but we have so many advantages also for simple hill climbing. So we will see this hill climbing algorithm with the help of a problem which is known as Block's world problem. This Block's world problem here now we are going to solve as example of hill climbing technique, and this is also of informed search algorithm. So Block's world problem is of informed search algorithm, informed search, right? So what is Block's world problem is, we were given the initial state with the with 4 different blocks, block A, D, C, B. These are all the different blocks, right? So in these blocks, this is the initial state, and these blocks are named with a character on their front face, right? This is the initial state, and we need to arrange the blocks of this into this format. So the blocks are arranged from the bottom as A, B, C, D. So this is our goal state and this is our initial state, right? So this problem we are going to solve with the help of this heuristic search, which is a hill climbing technique, and also this is a simple hill climbing technique. Okay, and here the optimization or the solution of this problem depends upon the heuristic function that we select. You have to select the heuristic function in such a way that we get the optimized solution. Okay, here I am selecting the heuristic function h of x. So h of x, my h of x is heuristic function here, so, right? And I am selecting a heuristic function in such a way that when I move a block, so for example there are some constraints here. When you are arranging blocks to go to the goal state, there are certain constraints to be followed. When you are arranging blocks, the block can be moved from the top of the given state and can be placed either on the floor or on the top of the other block. that is one constraint, and at a time we only move one block at a time. We don't move all the blocks together, we only move one block at a time. So the moved block can be placed either on the floor or on the top of the other block. So these two are the constraints that we consider. Now we are going to define the heuristic function. So in this example, the heuristic function in this problem, the heuristic function I am defining is, how I define the heuristic function is, suppose when I removed a block from here and I placed, so here what I am doing is, so I moved a block A and placed on the floor. So I will check whether this is my goal state or not. So I have to compare this with the goal state. So how I compare? So programmatically, if we compare, we will find out the heuristic function of any particular state. So this X is the state, right? So in that particular state we will find out. So for example, when I find out the heuristic value of the block B, I will check for the supporting blocks under B. So there are no supporting blocks under B in this state, right? So we need to do nothing. I will check the supporting blocks under A. So under A, in the goal state, there should not be any supporting block, right? No supporting block. Here also we don't have any supporting block, so no need to do anything. And check for B. So for B, I am checking the supporting structure. The supporting structure for B in the goal state is A. Supporting structure means the blocks under the block we are considering. So I am checking now for B, right? So under B, in the goal state there is one block, right? But in the current state what we are checking now, there are no states, right? So nothing to do. So here my heuristic value is 0 for this also. And also so this is for B and A. Now we completed, right? And I will write once again so that you clearly understand. So my current state will be C, B, A, and I placed D on the top floor, right? So now my in current state I have to consider each and every block, right? Here now first I consider block D. I should compare this block D with the goal state, right? Here in the supporting structure of block D, in the current state there are no blocks, but in the goal state there are 3 blocks, but in the current state no blocks, so we need to do nothing. And coming to A, in the goal state also there are no blocks, here also there are no blocks, so nothing to do. And consider now B. In the goal state there is one block below A, and here there is one block below A, so it is correctly placed. So below both are same, right? Both are same. So I will add +1 because one block is correctly placed, right? And consider now C. B is completed. C. Under B, under C there are 2 blocks BA in the goal state. Under C, here also in our current state 2 blocks are correctly placed, so I am adding +2. So for this state my heuristic value is 3. So I define the heuristic value in such a way. So I will give you one more example for this heuristic value, how to consider. And so I am representing one more state, right? One more state. I am taking one more state as an example. Here I am arranging like this. I will take CB and I have performed 2 sequential steps. So I got D and I got A on the top of D. So this is my current state, for example, you consider, right? So I have to calculate the heuristic value of this state to know whether it is better than the previous state or not. So I'll consider each and every block to calculate the heuristic value. Okay, so I'll consider B first. In the goal state, there is one block under B, and here under B there is nothing, so nothing to do. And consider